here's our last video for applications of exponential equations. We're going to talk about continuously compounded interest, and we're going to find out something about this new number called E. It's been such a wet and rainy day today. The kids have just been staring through the window all morning. If it gets any worse, I'm going to have to let them in. How do you know that Santa is really good at karate? Because he has a black belt. And last one. What's a frog's favorite type of music? Hip hop. All right. So we're gonna start off figuring out what basically where the last video left off with that formula that A equals P times 1 plus R over N to the NT power, and use that to talk about what E was, remembering that P was the principal, so how much you invested, R was the rate you invested it at, N was the number of times per year that it was compounded, the interest was compounded, and then T was how long that was going on for. So, quite a long time ago, there was this thought about, kind of was the most amount of money that you could make off of putting, money at a savings account. So the thought was that if what happens if you invest in $1, and just using one, because it's easy, at a rate of 100% for 1 year, and then it's compounded one time per year. So I guess that'd be compounded annually is the way we would say that, compounded annually. So basically, what that means is that P equals 1, R equals 1, so as you move that decimal place 2 times, so R equals 1, T would equal 1, and then N would also equal 1. How much money would you make? So from the formula, we know that A equals, so 1 times, so 1 for the principal, and then times 1 plus the rate of 1 over the number of times compounded per year, which would also be 1, all to the, and then N was 1, and then times T, which is also 1. So basically, how much money would you have if you saved $1, and then you got 100% interest back at the end of the year? And so the idea would be that, if I save $1, and then how much, so we can calculate that. So I'm going to throw that to calculator. So 1 plus 1 divided by 1, all to the 1 times 1 power. So we find out that that's 2. So if you put $1 in and you got 100% interest back, you would get $2 back at the end of the year. So basically the idea was well, what happens if we compound it more and more? So we saw, with the other video that the more you compound something, the more often you compound something, the more money you get back. And so if we just instead look at, say, well, what happens if we change that? Everything else stays the same, but we change N to 10 now. So it gets compounded 10 times per year. Just throwing kind of a number at it. So I'm going to change N. And so the idea is with that you don't earn as much interest each time. Now you're only earning 1/10 of the interest, but you earn it 10 times per year. So notice how the 1 over 1 became a 1 over 10. So we don't have as much interest now being earned each time, but we're earning it more often. So let's look back at the calculator. I'm going to change that to a 10. So I can edit my equation real quick. Change this to a 10. Change that to a 10. And now we earn $2.59 instead of just the $2. All right, so the more times we compound it, the more money we get, because remember, with the compound interest, your interest starts to earn interest. So what happens if we bumped up to 100? So n now becomes 100 times per year. So I'll go back and edit my equation real quick. So now we're earning a smaller amount of interest, 1/100th of the interest each time, but we're earning it 100 times per year. So that's $2.70. So we're seeing it's increasing more. Okay, what if it was 1,000 times per year? Oops. $2.72 now. So that didn't increase as much this time. So it went from $2 to $2.59, then to $2.70 and $2.02. So we can see the amount that's changing is decreasing each time, even though we're increasing the number of times compounded by a lot each time. And so the next idea was like, well, what if it keeps going? What if we do it instead of 1,000 times, we do it 1,000,000 times per year? So we need 6 zeros for 1,000,000. Ooh, not much change at all. Went from 2.717 to 2.718. What if we do it 1,000,000,000 times? So we need 3 more zeros. Oh, really? Not much change at all. Like, we have to go all the way to the 5th decimal to see a change there. And what if we go to 1,000,000,000,000 times a year? So 3 more zeros. All right, and so on that one, we have to go all the way to the 6th decimal to start seeing change there. So it seems like the change is really slowing down. And so this is what E is. So we have a button here on the calculator. On this calculator, it's over here it's above the equal sign, above the pi. It's above, I have this little e and this capital E. So on this calculator, it's just the little e. And if I hit little e to the 1, oh yeah, this one doesn't show me. I'll show you on the other calculator, but we find out what E is equal to. And so, but we see that it's getting closer and closer to 2.72. That's kind of where things start dropping off. So that's where E came from, is that idea of what happens if we compound it so fast that we can't even think about it so many times per year, just little milliseconds over and over and over again, but we just get little tiny chunks of that interest each time, that there's a limit to what E becomes. And so that's what it's kind of like pi. We've been able to figure out what pi is equal to pretty far, but still something keeps growing. So it's the same type of number as pi. It keeps growing and growing and growing. It's longer and longer and longer. It's an irrational number. And so on a Texas Instruments calculator, you'll have an E button. If you're using a scientific calculator, there's an E button you see here that says e to the x. And so what I typed in was E, and then I made that exponent a 1. So we see that E is equal to 2.718281828. And it actually looks like it's repeating, but it actually doesn't. It's an irrational number, so it's a never-ending, never-repeating number. If we went further along in the number, we could see that the pattern stops. The apparent pattern stops. So that's what E is. This is where we find it on a calculator. So you should have this LN button, and should have a button that says log right above that, and you should know it says 10 to the x right above that. And we're going to talk about what those things are later on in this unit here, as we're trying to explain the logarithms to you guys. But right now, you just need to focus on this E to the x button. So pretty much every calculator has this. So an E button. So you want to go ahead and make sure you can find that on your calculator. So we're talking about using this idea of continuously compounding here. So when you see this word continuously, we have a new formula that goes with that. And so it's similar to the one we were just using. And so instead of A equals P times 1 plus R over N to the NT, now that N is actually a number that just keeps getting bigger and bigger because we're compounding more and more and more, we can't use it anymore. So we have this E value here, this theoretical limit to how much money could grow. So you'll notice that what is similar to between the two formulas is that they both have a P value. So how much money is being invested, at what rate is it being invested at, and then how long is it being invested. So those things are sticking around. So it's a simpler formula. A equals P times, and I like to put that dot there to really accentuate that those exponents are only on the e, they're not on the p. It's something I've noticed over the years that students struggle with a little bit. So p times e to the RT power. And so p is still the principal, r is still the rate, and we need to turn that into decimal, and then t is still the time in years. So as we look at this problem, we'll notice it's going to give us some pretty similar information. So Aaron puts $500, so there's our p-value, into account for school expenses. Their account earns 2% per year, so there's our r value, or 2% interest. It's compounded continuously, so what that means, what that means is that you're going to use this formula here. So anytime you see that we're continuously, we use the PERT formula, not this formula. So, and then how much will be in the account after 7 years? So there's our time. So let's plug those numbers in. A equals P, which was $500, times E. So E is a number that we know the value of. It's not anything that you need to it's not a variable you need to solve for or anything like that. The rate is, so 2% would be 0.02, and then time was 7. So just like before, it's a good idea to put parentheses around this. I'm just going to type that in the calculator. So 500 times e to the 0.02 times 7 power. I hit my E button, caret on this one. A lot of times with those other calculators, the caret will automatically pop up. And then times 7, put that in parentheses. Again, you have to put that in parentheses or your calculator probably will mess it up. I'll show you that how this one would mess it up also. So $575. I'll type it the wrong way just to kind of show you. Caret. So if I just did 0.02 and then times 7, we get a completely different number. So one way you can kind of tell if you're doing things right is that we start off with $500 and we got $575. The answer should grow, but it shouldn't go crazy. Like our second answer was almost over 7 times higher than what we put in, which is way too much money to be making off an interest. So here we're seeing we're just gaining $75 versus over $3,000 from this 500. So that's just way too big of a number. Kind of let you know that something went wrong with how you typed it. So 575, and the 6 rounds up to 3, so 575, 14 would be my number here. We'll make sure we answer that question right. How much would be in the account? That's an A question there. So just like the last lesson, really we're being careful about how you read things, but the formula is easier this time. Less things to worry about. Let's see, in 1 year, so there we go, there's information right there. In 1 year, so there's our time. Cole wants to buy a bicycle that costs $500. If he opens a saving account that earns 12% interest, which good luck finding a saving account that'll earn you that much interest. Compounded continuously, so they're just saying that we're going to use this PERT formula. How much will have to be deposited is the principal. So the principal here is the question. We don't, how much is the principal? So that's our question. All right. And he wants $500 to be in there when he's done. And so that would be our A. So we know A. So just like last time, we know what A is. So 500 equals P. And again, I like to put that dot there. It really helps a lot of people. E, R, so 12% is a decimal, would be 0.12, and times 7. So basically what we have here is like 500 equals P times some number like 7. And then the idea, we just want to get rid of that 7 before we can do that. So what we need to do is we need to figure out what this is equal to so that we can divide it to there. Okay. So I'm going to go to my calculator and say what's e to the 0.12 times 7. And using parentheses around that. 0.12 times 7. Chances are it's going to be a really long nasty decimal, which again, we don't want to round that during this. So kind of your choices are to say, well, we know we made a plan to divide 500 divided by that. And so again, on this calculator, I can just tap It'll bring that number down for me, or you can look for that. If you have a TI, you have that second and then the equals button says ANS. You can use that to help you bring down that number. And then we find out that the principal would have to be $215.86. A different way we could have typed it all at once would have been saying, oh yeah, we know we want to divide, and then we want to divide by e to the parenthesis 0.12 times 7, close those parentheses, and of course we get that same answer. So if you want to type it in all at once, not have to worry about the rounding, then it's, that's a way to do that. So, or you can use the second answer. So a couple different ways. So at $215.86. So find out that P so make sure you're reading the question. How much would he have to deposit as the principal? So just reading that. All right, last example here. So Reggie inherited some money from his grandfather and put it in a bank that earns 11% interest. There's my interest rate. And then seeing that compounded continuously lets me know that I'm using that PERT formula. After 2 years, there's my time. Reggie has a $10,000 in the bank account. So that's the amount that's in there now. So that's our A value. How much interest did he earn? Oh, here's a different question altogether, right? So, but we've seen problems like this in the last video. So we know A, we know T, we know R, and the question is I, right? What's I equal to? Well, remember that A is equal to P plus I. So we're going to need to find the principal and then subtract it from the amount in order to find the interest. And so just like we did last time, we're going to find that principal first. So my amount in the account is 10,000. We need to find the principal. So that's P times E, since we're compounding continuously. 11% would be 0.11 times the 2 years. And we're going to put all that in parentheses up there. So just like last time, I'm going to take 10,000 and then divide it by all of this to figure out what P is equal to. So I'm going to go to my calculator and do that. Clear that out. 10,000 divided by E caret parenthesis 11% times 2 years. So that's $8,025.19. So that 7's going to round up to 18. Then I want to set, all right, so there's my $8,025.19. My column in place. So we said I want to take A minus P to figure out what I is. So 10,000 minus 8,025.19 will be my I value. So 10,000 minus this thing. So $1,974.81 will be my interest. $1,974.81. Oh, I forgot already. $1,974.81. There's my interest. So be really careful as you're reading those questions. Make sure you're answering the right version. Again, it's really easy to do all the math right, but then only find the principal and then put that in, and it's going to tell you wrong. So, and then if you read through the explanation of the problem, if you do get it wrong, it should highlight for you what you've done, and just be careful not to make those mistakes multiple times, and it bogs you down. So on this, you want to do section S14 on the Algebra 2 for IXL. At the point when you get to 75 score, that's where we want you guys to stop, because after that, then they're going to start having you try to do problems that we don't know how to do yet. We are going to learn to do that pretty soon here as we introduce logarithms to you. So hope this went well for you, and you have a really wonderful day, and take care of yourselves. Bye.